On Vancouver Island, a series of strange and lethal symptoms strikes residents without warning. Investigators are in a desperate search for the cause of the deadly illness. To solve the mystery, they must hunt for clues in the most unlikely places. But even as they close in on the location of the killer, the evidence points to one terrifying conclusion: it is all around them. Some of the names in this program have been changed. Vancouver, British Columbia, Canada's West Coast metropolis. A high-tech city on the edge of wilderness. Across the bay lies Vancouver Island, stretching almost 300 miles along the Canadian coast. This island is home to immense old-growth forests, ancient woodlands that make it a mecca for outdoorsmen. But for travelers and residents alike, that wilderness would soon reach into the heart of civilization in a most alarming way. In 1999, Marie Benson was rushed to the island's main hospital in the city of Victoria. She had been sick for several days with an excruciating headache and a high fever. Now, she was delirious. In the ER, doctors diagnosed her with meningitis, a raging infection that causes swelling around the brain and spinal cord. Soon, her organs began shutting down. Within hours, despite the doctor's best efforts, Marie Benson died. Doctors wondered how had an otherwise healthy young woman died so suddenly. At autopsy, the medical examiner took tissue samples to find out. What they didn't know was that these samples held a rare and dangerous killer that would soon overtake the island. Over a year later, the mysterious disease struck again. Arthur Labe was a self-employed house painter who had lived in Victoria most of his adult life. For the past several weeks, he had been suffering from flu-like symptoms, but he thought he could ride out the illness. As the summer of 2001 wore on, he developed chest pain and a dry cough. Then he started coughing up blood. That evening, he told his wife about how he was feeling. They were scheduled to leave for Germany the next day to visit with family. It was a trip they had been planning for years. He didn't want to ruin it.
He was feeling pain in his left side. And I thought probably because he walked a lot and he was usually very active and a kind of a workaholic. Then he told me that he had been spitting up blood. So I began to worry and told him he should go to the doctor.
At the Royal Jubilee Hospital in Victoria, Arthur was referred to a specialist in respiratory illness and sent for x-rays. Taking a medical history, the doctor asked Arthur if he was a smoker. In fact, Arthur had quit more than 10 years earlier.
Whenever you meet someone who's been a smoker and who's coughing up blood, obviously the first concern is of an underlying tumor, or in this case, a primary pulmonary malignancy.
A shaded area on Arthur's chest x-rays troubled Dr. Paulson.
Well, his x-rays were actually pretty subtle. The right lung was totally clear, but at the root, or just adjacent to the root on the left lung, there was a very ill-defined shadow.
Arthur imagined the worst.
See that area right here?
He worried how it would impact his wife and his daughter, Angela.
His doctor had suggested it may be a tumor, it could be cancer, it could be a number of very serious things. So Dad was scared.
The doctor recommended Arthur undergo a bronchoscopy, an exploratory procedure to determine what the shadow on his X-ray was. Inserting a hollow tube fitted with a tiny video camera down the patient's windpipe into the lungs, the doctor looked for the cause of bleeding and any tumors. As the doctors worked, Arthur's family waited anxiously for news.
We didn't know what the doctor would find. It really depended on whether or not there was something wrong with Dad, if he would be able to go on this vacation that he had planned. He wanted to go on this trip, so there were a lot of things up in the air at that moment, so we were quite nervous.
The bronchoscopy took over an hour.
Procedure itself went fine. It was not complicated, and he had basically normal airways. You could not see any obvious tumor or polyp within the airways. In fact, I couldn't even find a blood trail on this occasion.
The test had found no obvious dangers. The source of Arthur's symptoms remained a mystery. As a precaution, the doctor removed a tissue sample and sent it to the lab for testing.
Hello, folks.
Once Arthur recovered from the anesthesia, the doctors gave him the preliminary results. Arthur and his entire family were relieved that his lungs did not look cancerous. But the doctor couldn't make a final diagnosis until the lab report came back in several days.
So I was pleased to be able to reassure him somewhat that I didn't see an obvious tumor. Although not having all my samples back, I couldn't give him a definite answer.
With this good news and feeling well enough now to travel, Arthur decided to take his vacation. Arthur and Carol flew to Germany the very next day. As the Labes were heading overseas, lab technicians at Royal Jubilee Hospital tested Arthur's lung sample. They found no malignant or cancerous cells. But while checking for tuberculosis and other bacteria, the techs did find something unusual. Arthur's lungs were infected with a strange fungus, Cryptococcus neoformans. Common to Vancouver Island, this fungus had almost never before been linked to major health problems among healthy residents. But in Germany, the Labe's dream vacation was quickly turning sour. Days after they arrived, Arthur began complaining of severe back pain. His son-in-law took him to the local hospital. As they drove, Arthur's pain became unbearable.
Has it been getting worse than that?
His head was pounding, his fever soaring, and he was becoming delirious. To the German doctors, the symptoms suggested he was suffering from swelling around his brain, a condition called meningitis. A neurologist took blood samples and withdrew spinal fluid from Arthur to check for what might be causing his illness. But because the pain had started in his lower back, neither Arthur nor his family connected this sickness to his lung problem.
They told me that they really didn't know what it was, but he was going to be in the hospital for a while because they suspected meningitis. Then I really got scared.
The lab detected a high white blood cell count in Arthur's blood, which indicated that his body was fighting some type of infection. The doctor's diagnosis? bacterial meningitis. They put him on massive doses of antibiotics to fight off any bacteria in his system. In all, the physicians tried 6 different medications, but Arthur didn't respond to any of them. His pain became more intense as his condition deteriorated. The German neurologist told Carol he didn't think her husband was going to survive.
You should probably call your family because we are doing everything we can for him and he's not responding and it doesn't look good. So then I really panicked.
Desperate for some way to help her husband, she called their daughter Angela in Vancouver and told her of the grave diagnosis. Half a world away, Angela Newman was just starting her day when she got the call.
I'll see what else we might be able to find out, and I'll call you back as soon as I've spoken to Dr. Polson.
She was stunned by the news that her father did not have long to live. Searching for help, she consulted with Arthur's doctor in Canada. Dr. Polson had examined Arthur before he left on his vacation. She hoped he could help. She explained what was happening, and the doctor reached a startling conclusion.
He said, your dad's test results came back with Cryptococcus, which is normally nothing to be alarmed about. It's something that people have, and if their immune systems are intact, they're able to fight it off. And so I didn't even think twice about mentioning it to you. But in your dad's case, it has led to meningitis, which happens in very, very rare cases.
Well, presumably, I don't know.
If Cryptococcus was the cause of Arthur's illness, the German doctors had no idea. They hadn't been doing anything to cure it. Because antibiotics only treat bacterial infections, they were useless against the Cryptococcus fungus.
My first question to Dr. Polson was, can this be cured? And he said, yes, if there's enough time. I don't know how bad it is at this point. I don't know what stage it's at.
Dr. Polson thought that Arthur's rapid decline was puzzling.
At the point I met Mr. Labe, I had no evidence that his immune system was not up to par. So it's very unusual that he would get this sick.
Polson contacted Arthur's doctors in Germany.
Hello, Dr. Hensel. It's Dr. Polson calling from Victoria, Canada.
He relayed his biopsy information.
There's no cancer seen, but I'm growing Cryptococcus. That's right, I understand.
He then recommended medications to treat Cryptococcus. The German doctors put Arthur on the antifungal medication right away. Now all they could do was wait to see if his body would respond. Back in Canada, Dr. Polson decided that Arthur's condition was so unusual that he should contact the Vancouver Island Health Authority. Microbiologist Dr. Pamela Kibsey had never seen Cryptococcus affect a healthy person so dramatically. The fungus spreads like pollen on spores through the air. Normally, it's not that dangerous, unless it was now changing in some way.
I think I was worried that there may be more cases out there that we weren't aware of. So the first thing I did was alert all my other colleagues in pathology to be on the lookout for more cases.
Even as public health officials put out the first alert of a severe Cryptococcus infection, the fungus was spreading. Some 50 miles away from Vancouver Island, Brian and Kara White lived on the Canadian mainland. An avid outdoorsman, Brian started to feel strangely sluggish in the late summer of 2001. Suffering from chills and a fever, he thought he was coming down with the flu. Eventually, the symptoms subsided, except the chest pain. It only grew worse. Within hours, Brian was rushed to a Vancouver emergency room, convinced he was having a heart attack. His wife, Kara, couldn't believe what was happening to her husband.
Brian has always been an incredibly fit, outdoorsy, healthy guy. So for him to get something of this type was just kind of like being hit by a bolt of lightning.
ER doctors hooked Brian up to a heart monitor and did an electrocardiograph. The doctors quickly determined that Brian was not having a heart attack. As the chest pains continued, Kara White became more concerned.
It was quite clear that this case was somewhat perplexing. So they right away concentrated on the area of the chest, but they didn't even know if it was lungs initially. But then as they narrowed it down to lungs, then they saw the growth on the lungs.
A chest x-ray revealed a large suspicious mass. Doctors told the Whites that it looked like Brian had cancer. Over the next 2 weeks, Brian endured a brutal regimen of testing.
As well as x-rays, he had CAT scan and he had blood tests. Everything that was possible to go over him with a fine-toothed comb was done with Brian.
Finally, Brian underwent a biopsy so that doctors could obtain a sample of his lung. The retrieved tissue was sent to a lab where it was examined and cultured. The results came back negative for cancer, but positive for a fungus. The findings were confirmed. Brian had Cryptococcus. These extreme symptoms were so rare, to see 2 cases within several months was more than just unusual. It was alarming. Health officials feared that the Cryptococcus was transforming, morphing into something much more dangerous than they'd ever seen before. In the late summer of 2001, an unusual infection caused by a fungus known as Cryptococcus had struck 2 residents of Vancouver Island. Public health officials in Canada put out an alert for patients with flu-like symptoms who weren't responding to antibiotics. Brian White turned out to be one of a half-dozen patients who fit that description. In an average year, doctors would see just 1 or 2 cases related to the fungus in patients with compromised immune systems. All that was starting to change.
I think our worst fear is that what we're seeing is the tip of the iceberg in the sickest patients. And is this the beginning of an outbreak that's going to affect a whole lot of people?
Searching for clues, health officials decided to take another look at tissue samples from the infected patients. Technicians performed serotyping tests to examine the organism's structure and help identify it. What they found was surprising. They were dealing with a strain of Cryptococcus known as Neoformans gattii, a strain that had never before been seen in Canada, and one that could be deadly.
The new strain that we're talking about, variety gattii, is much more virulent. It's able to cause illness in people with normal immune systems.
Microscopic spores of the fungus can infect the lungs. Left untreated, the infection can spread to the central nervous system and all through the body, resulting in death. This strain is most commonly found in tropical parts of the world, where it lives in the forests.
It's been described quite commonly in Australia, where it's been associated with the eucalyptus tree, and also in South and Central America and Africa, where, again, the eucalyptus tree has been a common source for it, but some other tropical and subtropical trees as well.
Cryptococcus can also grow in soil and rotting wood, leaves, and mulch. Health investigators took environmental samples from around Brian White's home. With this new strain, investigators had no idea where it had come from or where to find it. Trying to pinpoint the source of the infections, epidemiologists began questioning all the people who had become sick. Now recovering, Brian White, the one patient who did not live on the island, detailed where he had traveled over the past year. Brian revealed that he had recently been to Borneo, a South Pacific island. Investigators wondered if he could have picked up the illness there. Then again, he had also recently been to Vancouver Island, hiking in the backwoods. Investigators would need to turn elsewhere for answers. Health officials next interviewed Arthur Labe's wife, Carol. After 6 weeks of recovery, Arthur was too weak to talk to investigators. Carol revealed that they had not traveled at all before Arthur became ill. This meant Arthur could have been exposed somewhere on Vancouver Island, even his own backyard. Believing he could have contracted the fungus from the compost or topsoil in his garden, they collected samples of each for testing. Samples from both patients' yards were sent to the University of British Columbia to be checked for Cryptococcus. Lab techs swabbed petri dishes and allowed the cultures to grow for 48 hours.
This is a very typical specimen. The capsules are quite long.
But the findings were not what they expected.
The results were all negative. We thought we might have a link, but we didn't turn up anything.
Desperate for answers, the health authority decided to contact their counterparts at the British Columbia Centre for Disease Control. The provincial CDC put out a wide-scale alert.
2 of the cases are from...
An unusual strain of fungus was on the rise. Doctors would have to be extra vigilant. The responses came in almost immediately. The first surprise, the CDC began hearing about an increase in Cryptococcus infections among wild animals. The dead creatures were sent to a lab for autopsy. Tissue samples were taken for testing. The results? Clear evidence of the new Cryptococcus.
In this case, we had an elevated number, all in animals with no pre-existing disease. So right away, that was highly unusual.
Beyond the wild animals, the island residents were also reporting an increase in respiratory infections among domestic pets. Something was attacking the animals' lungs and nervous systems. The vets took cultures from the sick animals. They too were positive for the fungus.
So around the same time as we were finding cases in humans, the veterinarians were finding cases in animals, and they assured us that this was a brand new finding. So again, this was just added more intrigue to this whole mystery, because where are the animals getting it?
Cryptococcus was proving to be one of a very few diseases that could infect animals and humans alike. All living things were potential victims. And public health officials began to confront their worst fear, that the outbreak might start spreading to the mainland before they could find the source. A rare fungal infection known as Cryptococcus was attacking residents of Vancouver Island on the west coast of Canada. Investigators from British Columbia's CDC had sent out an alert to area doctors trying to determine the scope of the outbreak. What they learned was alarming.
Carbon stain is positive, which is compatible with Cryptococcus.
Dr. Jean Adams read the alert and suspected that one of her patients had suffered from the same illness, but 2 years earlier. In 1999, Marie Benson, an otherwise healthy 40-year-old woman, had died from an untreatable form of meningitis. In light of the alert, Dr. Adams now suspected Marie died of Cryptococcus. Fortunately, the doctor had a frozen sample of the patient's spinal fluid. She sent the isolate over to the CDC office along with the medical records. At the British Columbia Centre for Disease Control, scientists thawed and cultured the sample. If this woman had died from Cryptococcus, it meant that Vancouver Island had a killer on its hands, and for much longer than anyone had realized. Soon they had their answer. The woman's tissue sample tested positive for Cryptococcus neoformans gattii. It was time to intensify the hunt for the source of the disease. They knew that the deadly fungus can live in trees, but in an island of forests, finding which trees would be the daunting task. As investigators raced to find the origin of the Cryptococcus, more residents on Vancouver Island were getting sick. An outbreak was underway. CDC investigators decided it was time to conduct a risk analysis. They needed to find a common link between the patients to figure out where the disease had come from. Local and provincial health officials reviewed all of the patient information. By the winter of 2001, they knew of over 30 cases of Cryptococcus.
West of there to Port Alberni.
The age span of the patients ranged from an 11-year-old child to an 87-year-old retiree.
Perhaps it's associated with chipping.
They had only one thing in common. They had all visited or lived on Vancouver Island. That still left several thousand square miles to investigate. On the hunt for clues, the researchers turned to the Center for Coastal Health, a veterinary agency. Because animals tend to stay close to their habitats, the investigators thought they might help locate the source of the fungus. Dr. Craig Stephen began conducting his own study of the animal outbreak by talking to pet owners as well.
So just like the people, we did a case control study for the animals. So we would find animals who had the disease and match them to animals that didn't, and then ask the owners about what they ate, their medical history, their travel history.
Medical investigators logged where the 24 infected pets had lived and traveled with their owners. What they found was that the animals and people had in fact intersected at one part of the island. was called the Douglas Fir Zone, and it contained a large public park. For microbiologist Karen Bartlett, the idea made sense.
This particular zone is very interesting because it's a different climate than anywhere else in British Columbia. There are different trees that are associated with that zone, and there are milder, warmer winters and very dry summers. So that was our first clue that the organism might be localizing because of the climate.
The wooded land had a number of places where Cryptococcus could thrive. Epidemiologists thought they had found the source of the outbreak. Now, they had to prove it in a park that stretched on for miles, containing thousands of trees. The team took tree samples, entering in the coordinates with a global positioning system. The system is accurate to within 5 feet. That way, they could find the exact tree again.
We went through a series of different sampling techniques. Initially, we were looking at taking what we call bulk samples, which is to basically take a baggie and scoop out any woody debris in, for example, the boles of trees or where a limb has fallen off.
The team of scientists spread out to process the park. In tropical climates, the virulent Cryptococcus is most commonly associated with eucalyptus trees. But investigators decided to cast a wide net, testing all types of trees in hopes of finding traces of the fungus.
One of the interesting things about the Cryptococcus neoformans gattii is that it has, as part of its life cycle, it needs to live in trees. And this was an unusual manifestation. Typically in infectious diseases, we're studying organisms that are passed from person to person. In this particular case, it's different that it's passed from trees to people.
Microbiologists at the University of British Columbia took the samples from the park and prepared them by putting them in a liquid solution. Then the solution was cultured to see if the fungus was present.
There are lots of other fungi that grow in and around trees, and so I was getting lots and lots of things growing on the plates, but not the thing I was looking for.
As the source of the Cryptococcus remained a mystery, the number of those suffering just kept growing. On Tuesday, February 26, 2002, Deborah Chow brought her sister Esther Young to a local Vancouver Island hospital. A long sickness of flu-like symptoms had taken a terrible turn. Esther had developed extreme back and neck pain, double vision, and a tingling in her hands. Deborah had never seen her sister so sick.
She couldn't lay down, she couldn't sit up, she couldn't stand up. The pain was so bad. And I was very concerned and worried.
The doctor put Esther on morphine for her terrible pain. Infectious disease specialist Dr. Wayne Gesquire was called in to assist on Esther's case. He ordered a series of tests, including a CAT scan and a spinal tap. As he reviewed the CAT scan, there seemed to be nothing unusual in the results. In the hospital lab, Esther's spinal fluid appeared cloudy, an indication she was suffering from a severe infection. Then, further testing showed that Esther's spinal fluid contained Cryptococcus. Esther's physician was alarmed at how an otherwise healthy woman could be so severely sick. He put Esther on antifungal medications and reported the case to the British Columbia Centre for Disease Control. It marked the 40th known Cryptococcus case since the outbreak had begun. As one more victim struggled for life, the source of her disease remained as elusive as ever, and the danger would only keep growing. In early 2002, medical investigators around Vancouver Island, Canada, pursued a new killer that had sprung up in their area. A fungus called Cryptococcus neoformans gattii. Dozens of residents had contracted painful, life-threatening infections. With an entire island at risk, health officials were racing to locate the exact source of the fungus before more fell ill. Scientists at the British Columbia Centre for Disease Control believed it was centered in one specific park where many of the victims had gone.
Very early on in the process, we realized that the cases were clustering on the east coast of Vancouver Island. There's a lot of trees on the east coast of Vancouver Island. And to be most efficient in looking for the organism, then we went to places where either cases of human or animal had been reported.
After several weeks of searching, scientists had a breakthrough when they located a Douglas fir tree that tested positive for the fungus.
We finally found a positive sample, at which point the whole picture changed and we realized that we were on the right track.
Microbiologists returned to the area where they had found Cryptococcus. Dr. Bartlett wanted to figure out how it was passed to people. The primary hypothesis that patients could have inhaled the fungus. She decided to test the air. The team used handheld samplers containing small strips that trap particles as they filter the air. Dr. Bartlett also set up air slit samplers on the ground and high in the trees throughout the park. These devices hold several petri dishes within a metal container. A battery-powered pump pulls air in through the device. The unique design mimics the human respiratory system. The next day, the scientists retrieved their samples from the park. They incubated the petri dishes in hopes that Cryptococcus would grow. The results this time were conclusive. They not only found proof that Cryptococcus spores were in the park, but that massive quantities were floating in the air.
We found not only the organism was in air all around the trees, but it was in high concentration around the trees. And this was the first time that this has ever been reported in the world.
The fungus was everywhere. They found 1,000 units per cubic meter, 40 times higher than ever recorded in the world. Cryptococcus was far too widespread to eradicate.
Even if there was a pesticide type of thing that you could use in the environment that would kill Cryptococcus, the problem is it's probably going to kill all kinds of other essential organisms that are important for the ecosystem, so that really isn't an option.
Even though investigators didn't know how the fungus got there, they needed to inform the public.
It was in a public park that some 700,000 people visit every year. And we had to find a way of getting the information out to people that there was a potential that they could get the disease by being in this really beautiful park that everybody wants to be in.
On June 6, 2002, the British Columbia Centre for Disease Control issued a public health advisory on Cryptococcus neoformans gattii. They also held a press conference.
They have never, ever in the world documented a cluster of patients like we have. This is the first time ever in the world that they've had so many patients. We consider this to be a new event.
Though previously unknown on Vancouver Island, a deadly form of Cryptococcus had affected Australia for decades. The Canadians sent slides of their strain to Australia for comparison. Scientists there performed genetic fingerprinting on the samples. They found that the Canadian fungus was identical to the Australian strain, Cryptococcus neoformans gattii. In the tropical regions of Australia, residents rarely develop sickness from the gattii strain because they build up natural immunities to it. Somehow, the deadly strain had leapt 10,000 miles of ocean and appeared half a world away. In Australia, the rate of infection was only 1 in a million. But Vancouver Island had already seen a rate nearly 10 times that.
We think that what happens is that the majority of people are exposed to this in the environment and their body develops immunity to it without them even becoming ill.
No one knew how long it would take for the Vancouver Island residents to develop a natural immunity. Until then, people of all walks of life remained vulnerable. Cryptococcus had already killed 1 and infected 52 others in the Vancouver Island area. It was only a matter of time before the fungus claimed its next victims. A deadly fungus was striking residents and visitors on Vancouver Island, Canada. Once a strictly tropical infection, a virulent strain of Cryptococcus had migrated to British Columbia, where the population had little immunity. In late summer 2002, nearly 3 years after the outbreak began, Esther Young struggled for her life against the fungus.
She was losing a significant amount of weight due to the nausea and unable to keep down food. Her headaches had reoccurred, and her overall fatigue got to the point where she found it very difficult to cope.
Despite treatment, she continued to develop a whole series of complications from the infection. She lost 35 pounds and became blind in one eye. Deborah Chow watched helplessly as her sister deteriorated.
I was feeling my sister was dying. And those were the words that came out of my mouth when I went and saw the doctor. I said, my sister's dying, you've got to do something.
Esther now needed help to breathe.
Despite the therapy, Esther's condition did not improve at all. In fact, she was slowly deteriorating.
Doctors gave her morphine for the pain. They also performed an MRI to see if the fungal infection had penetrated her brain.
At this point, it was not just a meningitis, in other words, infection around the brain. Now the infection was inside the brain, was now involving very integral parts of the brain, which was a major change.
The doctors told Deborah that Esther was not responding to treatment. On August 8, 2002, Esther Young quietly passed away from pneumonia brought on by the Cryptococcus infection. For health officials, the tragedy was doubly alarming. They didn't know why Esther hadn't recovered with treatment and why she was the only one not to respond to medication.
Why the drugs weren't working is still a mystery. We still don't know. Is there something unique about Esther? We knew she was a unique lady, but was there something unique about her illness? Was there something unique about the type of fungal infection she had that made this what appeared like virtually impossible to recover from?
Today, the big question remains unanswered: how to stop it.
Our first year in '99, we had 6 cases that we know of. The next year, in 2000, we had 11 cases. In 2001, we had 17 cases. And about midway through 2002, we already had 19 cases. So our worst fears are that, the outbreak is going to get bigger. Perhaps even tourists might be affected on brief visits to the island.
Warning signs are still posted in area parks, informing the public of the dangers posed by the fungus. Dr. Pamela Kibsey and her colleagues believe that the best defense is awareness.
We feel it's our responsibility to let visitors to the island and people who live here know that this fungus has the possibility of being a very severe disease.
Investigators still have not been able to track down exactly how the organism was introduced on Vancouver Island. But they do have several theories. They speculate that Cryptococcus arrived from Australia on imported plants or trees. Once in Canada, winds could have lifted the spores and deposited them in native trees and soil. For Dr. Craig Stephen and the rest of the team, the animal deaths have also shed light on another possible source. In 2000, several dead porpoises washed up on the shores of Vancouver Island. When Dr. Stephen examined the animals' lungs, he found them filled with Cryptococcus. Investigators wondered if the fungus could have been carried around the world on water currents and inhaled by porpoises. Whatever the source, health professionals can only prevent more deaths by educating the public to watch for symptoms. Early and long treatment with antifungal medication is the best weapon, the only weapon against the organism. Arthur Labe survived his bout with Cryptococcus. He continues to live with his wife Carol and his daughter Angela on Vancouver Island.
Life is just getting back to normal. Arthur doesn't work as many hours or as long as what he used to.
Brian White has regained most of his formerly active life as well. He lives with his wife Kara and daughter in North Vancouver. Having beaten the fungus, doctors believe Brian may now be immune to it.
I think it's made me feel a bit more vulnerable. I think I'm got a bit more of a spring in my step, a bit more clear about my priorities, about getting things done, about paying attention to the little things in life.
To this day, over 50 cases and 2 deaths from Cryptococcus have been reported on Vancouver Island. The outbreak is ongoing, and the fungus is still reported in high concentrations in the Douglas fir zone. Scientists continue to track it, hoping to find a way to stop the lethal disease. In time, the people of Vancouver Island may well develop an immunity. Until they do, the deadly spores are still a threat, an ancient killer floating in the air.